A 2-day assignment. Let's go. Alright, actually, I don't know why I pulled this up. I probably should have started with graph paper.
Are we gonna
Yeah, Allison, can you grab the graph paper? First the rain, and now this.
Yeah.
When does it end? Allison's got a rough life. Sigh.
I'm still mad at you for the fart.
You want to get one?
I handed.
Allison, what would Jesus do?
I'll take two. She got two for me. No, wait.
What?
Said, what would Jesus do?
I'll take some for this class.
Be kind to everyone.
You got that far out with him.
Would he forgive Trey?
Maybe you don't forget.
Corey was telling us yesterday at the lunch table that you farted in the bathroom and locked the window once.
Yeah, you don't talk about your fart. She's like, yeah, he always locks me in the bathroom.
Yeah, that's definitely happened. But was not lying.
Yeah, if that's like that was something she would make up. No. Okay, so if I have an equation like this, I'll throw a little something in there. What would this create on the graph?
An oval.
No, a circle. X squared plus y squared equals radius squared. It's a circle at center at 0, 3, which is right there, with radius of 30. Square root of 9 is 30. So it would look about like that. Okay, now if I add, by the way, we didn't do it, but, never mind, hold on, I'll get back to that. Say this is 16, so if we have a plus, and it's like this, what would that create on the graph? Yeah, you guys remember the book's word for it? Ellipse. I think plural of ellipse is ellipses, but I'm not 100% on that, but ellipse, yeah. So the x-intercepts would be at, well, plus or minus 4. And the y-intercepts would be the square root of that, so plus or minus 5. And do you guys remember how we found the foci, or what foci were? We did the big one minus the small one, and we square rooted it. So 25 minus 16 is 9, square root of 9 is 3. So, and also the foci were always on the major axis. So since the y has the larger intercepts, the foci would be on the y-axis. So it'd be at 0, 3 instead of. Anyways, so 1, 2, 3, 4. All right, and the foci would be at 3, which is kind of on top of mine. Oops. Anyway, that's what we did yesterday. We didn't talk about this yesterday, but guess what would happen if I did like x minus 1 squared like that?
You want to shift it left.
No, right. It would shift to right 1. So everything we did yesterday didn't have this, but you could, and just like the whole graph would just shift right 1. Just like, that goes up 3. Just kind of does the opposite. It affects the x direction, does the opposite of what it says. So that would be right 1. Yeah, we didn't really get into that though. And today it's going to look kind of like that, but there's something different. Can you guys tell me what's different with that equation?
You subtract it.
Yeah, the minus. The minus changes it. And let's see what happens. know what the x-intercepts would, like, what x value could I plug in here and make it equal 1? Is 4. And -4 also, right? And this would have to be 0. So 4 squared is 16. Over 16 is 1. And if this is a 0, that kind of goes away. So, okay, how about the y-intercepts? If I did like 0, 5, would that work?
No.
No, because this would be a 1, but this would be -1. So,
Negative.
huh?
So 0, -5.
Oh, well, -5 would come out the same, because when you square a negative, it's still
Wow.
positive 25.
Would you have to change?
So,
Would you have to change the x to twice its size so that it would equal 0? Equal 1?
yeah, but let's see. It's kind of a mess though if we do that. It'd have to be square root of 32, I guess. 5. Okay, we're not going to be doing that, by the way. That's not, and also that's not a y-intercept. That's just a weird point on the graph. But yeah, when you square root of 32, this would be 32 divided by 16 is 2. Anyway, yeah, that would work. We're not going to be doing this part. That's kind of a mess. We are going to use this, the x-intercepts. So the one with the minus, in this case it's the y value, does not actually have an intercept on these. So, let's see, 4, 0 has a point, -4, 0, 1, 2. This one, it's a lot harder to find individual points. It's not going to go this way. There is no y-intercept here. It's actually going to go this way. And you could plug in some different stuff and solve it, but it's like weird square root answers. Square root of 32, where would that be? It'd be like, I don't know, a little bit bigger than this. It'd be almost 6, like 5.6 or something. 5. Anyway, what's going to end up happening is it's going to kind of be going out like this. Okay, so the way we're going to kind of help us draw it is find something called the asymptotes. I feel like I've said this word a couple times before. Asymptotes are lines that the graph's going to approach but never touch. So they're kind of like boundary lines. And what you do is the slope of these lines is going to be the square root of what's under this one over square root of this one. So it's like the square root of 25 over 16. What's the square root of 25 and 16? The square root of 25?
5 4.
4. So y equals 5/4 x is going to be one of these asymptotes. That's the slope of the line. And y equals -5/4 x. It'll be another one. Positive version and a negative version. So do you guys remember how to graph y equals 5/4 x? Go up 5 and over 4. The rise over the run. There is no y-intercept out here, so it's kind of like you're starting at 0. So you start at 0, go up 5 over 4. You could also go backwards. You guys remember that? Down 5, back 4. Should be on the same line. Did they draw these solid or dashed? They drew these dashed. These aren't actually the answer. These are just like boundary lines. And y equals -5/4 would kind of be the same thing, but negative slopes go down and over. So it'd be like right there. And if I go backwards, right there. Okay. So to make the graph, basically you just kind of head out here towards. Alright, you kind of head out towards these lines, but it'll never touch the lines, but it'll get right up next to it and get closer and closer without ever touching it. So they're just kind of there to help us graph. Okay, by the way, I never said the word. These are called hyperbolas. So we had circles. You guys are not familiar with that one. It's kindergarten, right? Then we had ellipses, which means ovals, and then now we have hyperbolas. Is it hyperbolas or hyperbola? I don't know. Anyways, and they look kind of like that, just going out from the middle. Okay, so a couple things I need to know. The axis that actually has intercepts is going to be the term that's like positive. So in this case, the x term was positive. So it had the x-intercepts. The one that has the minus on it does not have any intercepts. So you could switch this around, like if I made it y squared over 9 minus x squared over 4. Okay, in this case, this would have y-intercepts at 3, but it would have no x-intercepts. So I just switched which one was being subtracted. So this one would look more like 3, negative 3. It looked more like this. I was going to say something else. What was it? Oh, and you still do the square root of this over this for the slope of the asymptotes. So it's the square root of the subtracted one over the square root of the other one. So remember on this one I did square root of 25 over 16 to get the slope of the asymptotes. So the slope of this one would be square root of 4, 2, square root of 9, 3, it'd be 2/3. It'd be like that. Did you do it again?
No, I didn't.
Yesterday I just assumed it was Leo.
If Trey wanted my ball on me, we probably could.
We would all believe you.
He's so good at convincing people.
It's not about him convincing people, it's about the pattern.
Yeah.
You can tell when Leo does it, he lifts his leg.
Yeah.
Why?
Remember the one that was really
Air pressure.
I had a really loud one yesterday.
Remember when Lydia farted really loud in the bathroom?
Blame it on the howdy girl.
No, that was a different one.
There's two.
Remember?
And the one she blamed the howdy girl was the
Those were
silent
so
one.
bad.
That was really bad.
The one at the door of the Isra
Okay,
room.
here we go. I'm good.
That was so bad. She made us all walk
I
through
think it
it.
was the same day.
You did that once in here too, like right before the bell rang,
Yeah, that was really fun.
on the way out the door.
We're about to walk through it.
That was bitter. I went to the office right after that. I was like, "Ooh." All right. Okay, sketch each hyperbola. Hyperbola? What sounds better, hyperbola or hyperbola?
Hyperbola.
Here, let me type it in.
Hyperbola.
Let me type it into Google, see how it says it.
He needs to.
There's a here in my book. Look.
It had.
Oh, it's my here.
No, didn't give me the option.
Oh, yeah.
Yeah.
Okay.
Just on the chair. Oh boy.
sketchy trackable. Okay, so is this one gonna have x-intercepts or y-intercepts on number one? X-intercepts. Where are the x-intercepts going to be? 3, square root of 9, plus or minus 3, yes. So put a dot at 3, 0, and negative 3, 0. Okay, it says graph the asymptotes. We're going to do that first to help us graph the hyperbola. So we had x squared over 9 minus y squared over 2 equals 1. Or, sorry, 4. Okay, so how did I find the slope of the asymptotes?
9
It's
over 4.
the square root of this.
4 over 9.
Okay, and it's also square root. So it's square root of 4 ninths. Which is square root of 4 is 2, square root of 9 is 3. So it's y equals, I'm just going to say plus or minus 2/3 x.
I did 3 over 2.
So the subtracted one's always on top. So, okay, so that means we need to go up 2, rise over run, rise 2 and run 3. Kind of in every direction, basically. So the line that goes up 2 and right 3 also goes down 2 and left 3, but the negative slope goes down 2 and right 3, or up 2 and left 3. So it always makes a rectangle, basically. And then we're going to draw dotted lines, like so. We do need this for an answer, by the way. Can't just draw the lines. You do need to write that. And then we are going to use the asymptotes. We're going to draw our graph towards the asymptotes, but they will never touch. Getting closer and closer, never touching. Reminds me of when I was little, my brother would eat cereal and I'm like, can we chew that any louder?
If it gets
The answer was no.
chips, it's really loud.
Yeah. We can't chew chips around Ava.
All that crunchy cereal and all that milk in his mouth.
Ew.
And he also liked to sit directly in front of the TV. Like his head like 3 feet away.
Feel a static from
I
TV.
think mine's
Now he's 40, he's got like 4 kids. I'm a pastor.
My favorite is fruit.
Captain
Or
Crunch is the
cinnamon
best.
toast
Did you guys
crunch.
know that the next eclipse in America is in 21 years?
What?
I'll be
So how old will you guys be?
21 plus 17.
37?
I'll be 48.
No, just 38.
Yeah, 37.
38.
Yeah.
Since
We're gonna not have to talk to each other for like
Wait,
10 years.
wait, I'm turning 18 this year.
It was 39.
Feel like,
Well, if you guys end up living in Bartlesville, you might still.
that's true.
They already know.
No.
You get 39.
I hate all my friends here.
Looking at Leo right in the face. Leo's like, I can see that. Okay. This one didn't have any denominators, so what are the denominators? 1. Okay. Is this going to have an x-intercept or a y-intercept? It's going to have an x-intercept. It's the positive one is the one that's going to work, not this one. So the x-intercept is square root of 1, which is 1, plus or minus 1. 0. Okay. what is the slope of the asymptotes? Square root of 1 over 1, which is just 1. So the slope is 1x plus minus. So that means it's up 1 over 1. So it's kind of a basic one.
And a history test, and a history essay. Yeah.
Oh, shoot, yeah.
Wait, we had a history test.
Yeah, I had a history paper due tomorrow.
We're missing.
Are you guys finally caught up?
Yeah.
I'm finally caught up to not be caught up.
Yeah. Oh, yeah, I'll track meet tomorrow and next Tuesday. So.
That's a lot.
I don't think it was smart was ever take their permission slips. I need a different one.
Shit, I have to change this. Sorry,
She just asked if I had it and I said, yeah, she did, okay.
Okay, so what's the problem with this one? It's number 5.
It's not fraction.
Okay, it's not a fraction, but also this number over here kind of needs to be a 1. So how do I turn this into a 1? Did some yesterday. Divide by 4. So if we divide by 4, what we get, those go away. You could say this is y squared, or you could say it's y squared over 1. X squared over 4 is 1. You want this number out here to be a 1. Okay, is this going to have an x or y intercept?
Why?
Y-intercept, because this time the y is positive. So the y-intercept is square root of 1, which is 1, but now we're on the y-axis. What is the slope of the asymptote? I almost rhymed, not quite. Square root of 4 over 1, which is square root of 4, 2. So, plus minus 2x. So that means rise 2, run 1. Rise 2, run 1. It's going to be a skinny one. That's not pretty. Yikes. Should I do a little bit better? Okay, I give up. They look a little more V-ish than U-ish. They're not quite the same as parabolas. They're similar, but Alright.
Yeah.
yeah, this one's just different. They happen to make a similar shape, but they work totally differently. Okay, just x, y equals 4. So what we're going to do on this one is make up some x and y values. So what could x and y be to multiply and get 4?
2, 2.
Could be 2 and 2. What else?
Negative 2,
Negative 2 times negative 2. You guys see where he's getting this from? 2 times 2 is 4, right? What else?
4 and 1.
4 and 1.
1, 4. Then those negative.
Negative versions of those. Okay, that's about it. What about if x were 0? Would that work?
Yep.
If x were 0, what would y be? 0 times what equals 4? Nothing. So there is nothing happening at x equals 0. Same thing with y equals 0. So the asymptotes are actually the axes. X equals 0, I don't know if you guys remember, x equals are like vertical lines. X equals 0 would be like the y-axis. Nothing's going to be happening there. Y equals 0 is the x-axis. Nothing's going to be happening there. So the asymptotes are actually just the axes. Okay, and let's graph these two. So 2, 2, 4, 1. Let's see, 4. We could have done like, I don't know if I want to, but 8 and 1/2, like 8 times a half. Or 1/2 times 8, way up here. So anyway, the axes are asymptotes. So our lines should be getting closer and closer to the axes without ever touching.
That seems like a good start.
Yep. Seems like a great start.
All right, try number 2.